The rate of diffusion is affected by the ratio of the surface area to the volume of a shape. If we look at a cube and measure the area of each of its faces, we get the surface area. This is how much space there is on the outside of the shape. And if we wanted to measure how much water can fit inside that cube, we're looking at the volume. This is the space on the inside of the shape. It's important that you can calculate and compare surface area to volume ratios in the exam and discuss them in terms of diffusion. So how do we calculate and compare the surface area to volume ratio? Find the surface area to volume ratio of this cube. So step 1, calculate the surface area. To work out the surface area of a cube, we're going to do the width multiplied by the length multiplied by the number of sides. So the width is 2 centimeters, the length is 2 centimeters, and the number of sides is 6. By doing 2 multiplied by 2 multiplied by 6, we get a value of 24 centimeters squared. Make sure that you remember that the unit for area is squared. So how do we calculate volume? Step 2, calculate the volume. So the volume of a cube is equal to the width multiplied by the length multiplied by the height. In this case, it would be 2 centimeters multiplied by 2 centimeters multiplied by 2 centimeters, which equals 8 centimeters cubed. Remember that the unit for volume is cubed. How do we use these numbers to work out the surface area to volume ratio? Step 3, simplify the surface area to volume ratio. So the surface area value that we got was 24 centimeters squared. The volume we worked out to be 8 centimeters cubed. This can be the starting ratio, but we need to simplify. We can do this by dividing by a common denominator, which in this case would be 8. If we do this, we end up with a ratio of 3:1. Now, ratios don't have units, so we don't include the centimeters squared or the centimeters cubed in this simplified ratio. The greater the surface area to volume ratio, the greater the rate of diffusion. So the surface area to volume ratio for each of these cubes would be 2:1 for this largest one, 3:1 for the middle cube, and 6:1 for the smallest cube. As you move from left to right, we would observe that the rate of diffusion increases. So there would be a low rate of diffusion at this end, and a higher rate of diffusion at the smaller end. This is why organisms are made of many tiny cells alongside each other rather than single large cells. For the exam, you need to know that the rate of diffusion is dependent on the surface area to volume ratio and what this means for the exchange of substances in living organisms.
Thanks for watching. If you want to take your GCSE revision to the next level, head over to launchpadlearning.com and check out our smart learning platform that's been designed to get you top results in your exams. We cover your whole specification and make revision fun with interactive quizzes, easy-to-follow videos, and more. You'll be kept motivated by your own AI tutor who's here to support you every step of the way. To check it out for yourself, click here. Or click here to keep watching a selection of the videos from our full GCSE Biology course. See you there!